Hello everyone, welcome to CivilPrep. I'm Krishna Gupta. This is a session on geography optional for today's paper, that is paper 1, which has come in the UPSC exam. Okay, I have went through the paper and I have seen that this paper, it was a very, you can say that it was very much of a conventional paper. There is no surprising element which I have found in this year's paper because most of the processes, conceptual based questions are very much there. Contemporary relevance, which is a part of the UPSC examination geography optional paper, where the links have been made between the various aspects. For example, the Himalayan rising, then the coral reefs, then we can say the development of waves, tides. Okay, so here we see that a lot of things have been asked, but they have not been giving any surprise element in this year. Okay, so thankful for to the UPSC that we can attempt almost all the questions without any nervousness or any kind of anxious part which we experience during the papers when there is a surprising element. So uh, here we will do one thing, that we will be going for the paper here like in wise of section. So I'll be discussing first for optional paper 1. Under paper 1 we have section A. So section A, it is consisting of physical geography. So first we'll discuss physical geography, then we'll discuss human geography, that is section B. Then after that we'll be discussing the Indian geography, where we have two other sections and we'll be discussing them quite detailed. Okay? So guys, let's move ahead. Let's start our discussion today. Okay, so first question here we have, explain the causes and causes of glacial lake outburst flood. Okay, so this is a GLOF event, okay, which we also call it as the glacial lake outburst flood. Basically, we see that this is one of a disaster. It is one of a disaster, or we can also call it as hazard. Better. This is a disaster, or we can also call it as hazard. Okay, when we talk about the disaster and hazard, we see that it is very well defined by Gilbert White. But when we look at the process, that is a GLOF event, this can be very well explained with the use of geomorphology. Basically, glacial lake outburst flow, it is an event which takes place in the regions of mountains. So under the mountainous regions, we see that there is presence of various glaciers. So these glaciers, they expand. Okay, sometimes they expand during the winter season, and during the summer season they retreat. Okay, so during the winter they expand, and during summer they retreat. So because of this processes, what we see here, that there is development of a accumulation of sediment occurs here at the end point of the glacier. So this accumulation of sediment, which gets deposited here, this act as a form of a dam, which we also call it as a moraine dam. Okay? So this moraine dam, this glacial retreat and this glacial, we can say that expansion, it can be explained very well. It can be explained very well under the periglacial cycle of erosion This periglacial cycle of erosion, this is given by, actually Peltier was one of the student, or we can say disciple of Davis. So Davis have not given one of a separate cycle of erosion for the glacial or the periglacial regions. So here Peltier has went through the cycle of erosion processes, and he has seen that what are the different areas where he can contribute for the development of cycle of erosion. So he found out this region, that is the glacial region, where the erosion and deposition processes taking place simultaneously. So here we see that there is a erosion processes being done by the glacier here. Okay, so the erosion, if we look at, it is done with the process of attrition, and plucking. Okay, because of the attrition and plucking of the various, we can say sediments and rocks, these sediments and rocks, they deposit here, and during the summer period, when there is the melting of glacier occurs, this results into the development of glacial lake. This glacial lake, it is formed because of the melting of the glaciers during the summer season. Now what happens here, sometimes because of either the dam, it weakens. So here when we talk about the GLOF, what are the causes? So number one thing, sometimes because of its long duration, the moraine dam, it gets weakened. Okay, and this results into the outburst flow, that is the GLOF event. Okay. Second thing, we see that because of climate change, in the contemporary time, we are seeing that already 1.5 degrees Celsius of temperature has risen, which has been given by the IPCC 1.5 degrees Celsius report, which is a special report on the global warming. So they have already specified this 1.5 degrees Celsius rise, which have already taken place since the pre-industrial levels. So in this part, we can see that this is resulting into the higher rate of melting of glaciers. So because of this higher rate of melting of glaciers, we are seeing a increased GLOF events in the contemporary time. Okay. Apart from this, we will also see that we'll also see that sometimes because of the earthquake events, the water which is present inside the moraine dam, it is basically resulting into the instability. Because of this instability, it results into the damage of moraine dam. Because of the damage of moraine dam, it results into the GLOF event. Okay, here we can give another factors as because of cloudburst. Okay, because of the cloudburst events also, there is increasing chances of GLOF event. Okay, so we see that these are the certain causes which is happening in the contemporary time resulting in the GLOF events. So here we can give certain examples. Examples like South Lonas, GLOF happened in 2020. So this is one of the major event which has taken place in 2023. So this occurred because of the earthquake activity. We will also see that the GLOF event, it has happened in the region of Tehri Dam. So here what happened? There is an avalanche has taken place. This avalanche, what it happened? There was a glacier. So a part of glacier, it just went out of this region and this fell into the lake. Okay, this fell into the lake. So whatever the water which was present here, this water, it splashed out. Okay, so this was part of glacier. Okay, this, I think this was Pindari Glacier. Okay, part of Pindari Glacier. So the water splashed out and it moved as a part of GLOF event. So we can see that one of the chances here, that is the avalanche. So avalanche also results into the GLOF event. So this resulted into the damage of the Tehri Dam. So here we see that these are the various reasons, various causes which are actually resulting into the GLOF event. So to look at this part, we will see that ISRO, they have used GIS system, which is part of systems analysis plus horology. They are trying to map. Actually, they have mapped the glacial lakes. These glacial lakes will be seeing that they are basically observing the expansion of lakes. So this is basically done in the Himalayan region. So that these lakes can be better managed to overcome, or we can also write prevent the disasters in the region. Okay, so this part we see that they have tried to use the GIS system. Okay, so under the contemporary time, we'll be also seeing that the NASA ISRO system, they have put forward NISAR. Okay, NISAR satellite system. This NISAR satellite system, it is taking an orbit in every 12 days. It is completing its orbital revolution. So here we'll be seeing that under 12 days, we can have certain data which will be used in the better way for the, we can say, the mapping of this glacial lake. And so this we can overcome the issue of the glacial lake here. Okay, so this is the first question we'll be seeing here, which we can write here. We can give interconnect it with the various streams. Okay, we can interconnect with the various causes, the disasters, the hazards, how it have been defined by the various theorists, and we can use this aspect here for the writing up. So this was the first question. Let's move to the next question. That is, what is solifluction? What are its impacts? Okay, so what is solifluction and what are its impacts? So here we'll be seeing that solifluction, it is one of a mass wasting process. Okay, if we see here that this is the triangle of mass wasting, so solifluction will be seeing that it is a part of, it will come here. So this will be the region where the solifluction will happen here. So what we see here, that this is the mass wasting and it generally takes place because of the freeze and thaw mechanism. which is basically a part of weathering. Okay, so this is a freeze and thaw mechanism which is taking place in the glacial and permafrost region. So permafrost region here it is very important. When we talk about the glacial and the permafrost region, this is also explained by the Peltier in his periglacial cycle. Okay, so this is also explained by Peltier in the periglacial cycle, where the freeze and thaw mechanism, it is one of the most important, we can say, most important weathering process which is taking place in the periglacial region here. Okay, so this we can see that this is a basic mechanism of solifluction where we can include it with the mass wasting. Okay, so this is also a slow movement of top layer of soil under the influence of gravity. Okay, it is moving under the influence of gravity when the top layer of permafrost it melts. Okay, so through this process we'll be seeing that this kind of periglacial process, it is majorly seen in the Arctic region, Antarctic region, and also in the regions where the glaciers and the permafrost regions are present. For example, the region of Himalayas, the Alps, the Rockies, the Andes. Okay, so these are the major regions, okay, which are outside the Arctic and Antarctic region, where we find this particular processes here. But when we see this process as one of the very important part, it is the region of Siberia, region of Canada, okay, Norway, Sweden, okay, Finland, Greenland, Iceland. So these are the major regions where we see this process happening. Okay, when we look at its impact, that what is actually the impacts of solifluction. What are the various impacts of solifluction? Here we'll be seeing that number one, it results into the avalanches. So under a slope, what we'll be seeing here that there is periglacial region. Okay, this soil region, it is actually freezed here. Okay, it is actually freezed, but when it will start to, so the same region here will be seeing that it will move down the slope under the influence of gravity. Okay, so here we'll see that the various part here of this soil, it will start to forward. Now, two things happens here. First thing, whatever the snow or glacier which is present above it, it will also start to move down. It will also start to move down, and this will result into the various disasters. Okay, so it may result into the avalanches because of the movement of the soil. Second thing, it may result into the disasters. Okay, like we can see here, the destruction of settlement, destruction of human settlement. Okay, this we can see it is normally happening in the region of Canada and also Siberia. So in Canada and Siberia, this thing, this solifluction, it is quite common here. Third thing we'll be seeing here, that is the loss of agriculture. We will see that in the region of the Arctic, Antarctic, and the polar regions, there the space, or we can say the soil, which is present with the people, okay, which is present with the civilization, for the growth of agricultural produces, it is quite less. So the regions where there is melting of ice, they use it for the agricultural processes also. So whenever this solifluction occurs, it results into the loss of agricultural produce. So here we'll be seeing that the various crops like wheat, various fruits, potato. Okay. So this agriculture, it actually gets destroyed. Okay. Fourth thing we'll be seeing here that this will also result into the infrastructure damage. For example, in case there is some electricity poles which is present here, okay, in case there is some kind of we can say the wire system is present here, or the sewage lines are present in this region, so these infrastructures, they get removed here. The infrastructure is removed, and this again result into the various kind of loss of infrastructure. Huge amount of economic loss is occurring because of this particular aspect, and yes, there is loss of life also, loss of life and biodiversity loss. For example, in this region, we'll be seeing that there are large amount of animals which are present here. Humans are also living. So under this avalanche, or we can say the solifluction condition, it results into the various kind of, we can say, the loss of biodiversity and life. For example, we'll be seeing that uh, the region of Siberia, there are wolves are living. Okay. Apart from wolf, if we go to the European region, there are antelopes, rabbits, in fact, dogs. So they get under the impression of this solifluction, and they also get flown out with the. Okay. So these are the various impacts which we can add up here as a part of the impact of the solifluction process. Okay. So we will see that this process is quite common also in the Himalayan region, where there is the thawing and freezing of the ice is taking place in the soil region. It is resulting into such kind of avalanches. So if we go to the conclusion part, if we go to the conclusion part, we will see here that this solifluction, to understand it, we need to have a geological survey and map areas where the rate of melting of permafrost is increasing to avoid disasters and hazards. Okay, so this thing we can add up in the conclusion part here, where we are linking it with the applied geomorphology, and we are also interlinking it with the part of the hazards. Okay, so guys, this is the question, the second question which we can look at here, interlink with the solifluction and the part of its impact. So next question here we have, with respect to the geological and tectonic process. The geological and the tectonic processes lead to the formation of nappes in the orogenic belts. Okay, so this is one of the question which is we can say which is quite very much peculiar. Okay, it is very much peculiar with respect to the development of the folds and faults and the geological processes involved here. So in this part, guys, we'll be seeing here first thing, what are nappes? Nappes you might be aware about. There is a folding process. Okay, so there are various type of folds. For example, this is symmetrical fold. This fold occurs whenever there is a compression. Whenever there is compression of plate. Okay, so this compression of plate, we will normally see that it basically happens because of the convergence plate boundary. So whenever there is a convergence is taking place, whenever the forces are applied, this results into the folding. So the one type of fold here, that is the symmetrical fold. Then we can see here that when the fold, it is not present evenly with the same angle here, this is called as asymmetrical fold. Okay, now in the same process we'll be seeing that there is a presence of a thrust fold or recumbent fold. So what happens here? The folding has taken place. Now the folding, it has been turned completely. Okay, and it is turned in such a way that this recumbent fold, it is moving in a particular direction. Now the same recumbent fold will see that when the thrust is still being applied. So I will see there as part 1 and this is as part 2. So the one part of the plate, it will present in some region, and the other part of plate, it will be present in certain other region. So this is the plate, part of this plate 2, and this is the part of this plate 1. So such kind of fold, okay, such kind of fold, this results into the, whenever there is the slipping of the two plates, okay, the two plates, they are folded together, but now they have broken and they have moved apart. So this particular process, it is called as nappes. Okay, so nappes will be saying that this is one of the process which is part of the orogeny. This is one of the processes which is part of orogeny. Okay, if we look at the orogeny is one of the process which is part of diastrophism. Okay, so under diastrophism, there is a slow movement of any landform. Okay, it is taking place, and here the forces which are applied here, they are applied in the horizontal manner. And the processes and the forces which are coming here, they are coming from the interior of Earth. Therefore, they are classified as the endogenetic force. Okay, they are classified under the endogenetic forces, which is further classified as a part of the Earth movements. Okay, so this is the Earth movement. This is basically the faulting process. Okay, it is taking place here. So this is classified as the Earth movement, where the endogenetic processes are acting, resulting into the horizontal movement of forces, which is a part of diastrophism. And under this diastrophism, there is orogeny process, which is actually a mountain building process. Okay? Now, looking at the question again, we'll be seeing that what geological and tectonic processes lead to the formation of nappes in orogenic belt. Okay. Now, we need to talk about two things here. We need to talk about two things here. That is, okay, we need to talk about two things here. Number one, the geological processes, and second is the tectonic process. So in this part, we see that when we look at from the geological perspective, this is basically one of the type of rocks, and these large rocks, they are classified under the plates. Okay. Now, under the tectonic processes, we'll be seeing that they are actually plates. And under the plate movement, we'll be seeing that when the two plates, they are actually colliding with each other, they are undergoing the process of convergence because of the convection currents. Okay, so here we see that it is undergoing a convection current here. So because of the convection current, it results into the suture zone, formation of a suture zone, where the folding and faulting occurs. This folding and faulting process, it is part of the geological process here. Okay, this process of folding and faulting, it is being classified as a part of the geological process here. Okay, so here we see that there is a development of convergence boundary. This convergence boundary, it is resulting into the folding and faulting, which is basically happening under the suture zone. Now, we will see here that according to the plate tectonic, these plates, they are basically, we'll be seeing that they are acting as a stress guide. Okay, and this stress guide mechanism, it is explained well under the elastic rebound theory. Okay, under the elastic rebound theory, that the edges of the plates, they will undergo the deformation, while the complete part of the plate, it will not undergo deformation, but only the edges part of the plate will undergo the deformation process. Okay, so folding and faulting, it is happening in this part here. Now, under the folding, we'll be seeing that there are compressional forces. Okay, so compressional forces, they are resulting into the fold. Okay, and the same compressional forces, they are resulting into uh, the fault. Fault is basically the breaking of plate. The breaking of plate. Okay, so this formation of the plate or deformation of the plate, it is now classified here under the part of the geological aspect here. When we will look at the continental plate majorly, they are made up of gneiss. Okay, they are majorly made up of gneiss. Okay, so this gneiss, or we can say that uh, it is one of the metamorphic form. Okay, it is one of the metamorphic form which have been a part of the continental nuclei. So these continental nuclei, they are quite strong here, but yes, they will also undergo the deformation process because of the application of the tectonic forces here, which is a convergent boundary motion happening. Okay. Now, it is not only the convergence boundary which is resulting into the such kind of condition, it can also be the transform boundary. Under the transform boundary, the two plates, they are moving past each other. These plates are moving past each other, and this is also resulting into the formation of nappes and faults. Okay? The nappes and faults, they are also formed in this particular situation. So this is the process. Here we'll be seeing that it is also majorly the here also we'll be seeing that they are majorly the compressional forces, which we can see in the geological aspect in this part. So this is one part we see that, which is an explanation for the development of the nappes, okay, in the orogenic belt. Now, when we talk about the orogenic belt of the earth, so here we can draw a map of world. Okay, so here we can draw a map of world, and here we can specify the various belts of earth where this kind of nappes is present. For example, Himalayas, which is present between the continental continental convergence. Okay, we can also see it under the Ural. Okay, so this is also a type of continental convergence. Okay, here we have Alps. So Alps is basically a part of oceanic continental convergence. Okay, here we have Rockies. So Rockies and Andes. Okay, Rockies and Andes. Both are also part of oceanic continental convergence. Okay, so in this regions we'll be seeing that the nappes are normally found here, okay, where the orogenic belts of the world are present. So we can see that there are various belts of orogeny, that is the mountain building processes present in the different regions of the world, and here we can find the presence of nappes which have formed because of the geological processes, and they have also formed because of the tectonic processes. Okay, so in this way we are able to map these nappes over the world with the help of this world map here. Okay, so this is basically explained by the plate tectonics. Okay, plate tectonics is very able to explain these processes here. Okay, where we can find the names and this other parts here. Okay, so guys, this is a question. We'll see that we can have a conclusion also for this question. Okay, so for the part of conclusion, I will be adding here the names are displaced plates from their region of formation, and this helps us to understand denudation chronology and the planning of fragile mountain region with respect to infrastructure development. So with this part, we can see that we can add this region over here, and we can have a case study also, the case study of uh, the main thrust fold, okay, the main thrust belt, okay, the central thrust belt of the Himalayas. Okay, we can provide a case study of the Himalayan region, and we can explain these processes if you have time, extra time, and if you want to add certain things here, you can show this in this particular area. Okay? So this is one of the question we'll be seeing that, which is not very peculiar, but yes, it is requiring a detailed information of certain aspects. Going to the next question. So the next question here we have with respect to the relationship between air masses and local wind. Now, this is a very simple question, what I believe. In this question, we need to explain what are air masses and what are local wind. Okay? And we need to establish a relationship between the two aspects here. So number one, air masses, they are the homogeneous composition of uh, the characteristics like temperature, pressure, moisture, relative humidity, and we can also see here the stability or instability. So these conditions we see that it is prevalent over the certain region. So this will result into the development of air mass. Now these air masses will be seeing that they are majorly formed over the high pressure region. Okay, they are majorly formed over the high pressure region of world. For example, if I draw a world map, so this is one of the zone of high pressure region of world, and this is another zone of high pressure region of world in the subtropical region, and another zone of this high pressure region is this polar high, and this is subtropical high pressure. So in this region we see the development of the this air masses. So here we can see one thing. For example, I am taking here an example of North America and South America here and Africa. Okay. So here we can see the presence of North America, Africa, certain part of Europe is also present. So here what I can see that in the regions where I have the presence of land, okay, the regions where I have a presence of land, there will be development of the continental tropical air masses. So here also in this region we'll be seeing that there is continental tropical air mass. Okay, while in the part of the sea region, we'll be seeing here the presence of maritime tropical. Here also we'll be seeing the presence of maritime tropical. While in the polar regions, we'll be seeing the presence of two air masses. That is, in this region, we'll be seeing that there is presence of uh, the polar continental. There will be polar continental, and in this region, we'll be having the presence of maritime polar. Okay, maritime polar air mass here. Okay, here also we'll be having basically this region, it is consisting the part of ocean, but in the southern hemisphere we have Antarctica. So here we have continental polar, which we also call it as CAA for Antarctica, continental Antarctica, and in the nearby regions we'll be seeing that there is presence of maritime polar. So this region will be seeing that we have various types of air masses, and these air masses, they are classified on the basis of either they are present on land or they are present in water. Second thing, they are present near the tropical region, they are warm air masses. They are present near the polar regions, they are cold air masses. But both the air masses, they will be formed near the 30 degrees of latitude and the 90 degrees of latitude nearby it. Why? Because these are the high pressure belt regions of the world which provide a suitable condition for the development of air mass. Now, if I try to see these conditions and if I try to see that how they are interlinked with the local winds. So looking at the part of local wind, I am moving to the next page. Then I'll interlink them. Okay. So here we'll be seeing that the local winds, these are the regional winds which are non-periodic in nature. Now, if I try to draw a world map of the world, so this local winds will be seeing that they are majorly regional winds and non-periodic in nature, and they are present during a particular season also. Okay. They may be classified under the seasonal part also here. For example, we can see the Lu, which is present in the northwestern and central part of India. They are present only in the summer season. Okay, they are present only in the summer season and they are not present during the winter season. Why this is happening? Why they are present during the summer season? Because there is development of low pressure region over the land and there is movement of wind from high pressure region to low pressure region, and this is resulting into the formation of Lu. Okay. So similarly, we'll be seeing that this local winds, that is the Lu, they are formed because of the presence of high pressure system in the cold region and the formation of low pressure system in the warm region. Okay, so the cold region we can interlink it with the polar, that is 60 to 90 degrees of latitude. Okay, where we see the presence of various air masses which are present over the land or oceanic region. While in the second part we'll be seeing that this warm region, they are majorly present between nearby 30 degrees of latitude. Okay, in the 30 degrees of latitude, the presence of this polar region or this warm winds, they are quite high here and they can be present uh, between the tropical and subtropical region. So when I try to look this aspect over the map, okay, I am drawing the map again. Okay, so in this region, we can identify certain areas where we have the presence of the different kind of winds. For example, here we have Chinook, is a kind of a warm wind. Chinook. Here we have Lu. Okay, here we have Sirocco. Here we have Doctors. Here we have Harmattan. Okay, if you look at the other aspect here we have Cone. Okay, here we have Nor'westers. Here we have Nor'easters. Okay, Nor'easters. Then here we have Boro. Okay, we have Boro here. Then can also look at the certain other winds, but these are the major winds we see that which are the local winds which are present in the different regions of the world here. Now, when I try to look at these regions, okay, I can see here that there is certain development of these winds with respect to the various type of air masses. For example, this Chinook wind, it is coming from maritime tropical. Okay, it is coming from ocean towards the land. Okay, this nor'westers, they are having an influence of uh, maritime polar. Okay, nor'easters, they are also having an influence of maritime polar. This phone, they have an influence of the maritime, the continental polar. Okay, this Sirocco, they have a presence of, you can see here in this region, there is maritime, the continental tropical, where we have the presence of the Sahara Desert. Here we have the presence of the Namibia Desert. Here we have the continental tropical. Okay. Here also we'll be seeing that we have the presence of continental tropical in this region, and in this particular area of the Siberian region, we have continental polar wind. Okay. So because of the presence of these air masses, okay, these air masses, they are having an influence over the development of these local winds in a particular region, different regions of the world. Okay. So we can interlink them with by drawing this map here, which will be able to explain our concept here better way. Okay. Now, looking at this part here, the relationship between the air masses and local winds. Okay. So both these air masses and local winds will be seeing here, they are helping in the various conditions. For example, this maritime polar or this northwesters will be seeing, they are helping in the cold waves. They are causing cold waves. This Chinook, okay, the Chinook winds, they are helping in the, they are called as snow eaters because they are expanded adiabatically. Similarly, we'll be seeing that the Sirocco, they are useful for the rainfall. Okay, these doctors, they are bringing here the warm winds from the ocean region, which is basically helping this coastal areas of this region. It increases temperature, and because of the increase in temperature, the relative humidity increases. Because of the increase in relative humidity, the temperature, it is pacified, or the climate of the region, it is pacified, or we can call it as moderation or moderate effect. So these are certain impacts we can see that which are being happening because of the presence of these local winds. Okay. Here, this Boro, it can cause cold wave, also blizzards. Same thing with the phone also. Okay. Same thing also happens with the phone, which also causes the cold wave and the blizzards in those particular regions. Now, these things or these winds, they are local in nature, but the pressure system, okay, or the temperature or energy which is provided here, it is basically done by the presence of these air masses which are present over the different regions of the world. So in this way, we can explain that how these particular phenomena, they are taking place over the world. So you can just conclude here with the phenomena like understanding of these air masses and local winds, they can help us to plan better for the agricultural system or the climate regulation, or how it can exacerbate or exacerbate the climatic regions of the world in the times of the climate change. Okay? So we can give this conclusion here and we can end this answer. Main thing was the concept and the topic. Now moving to the next question, here we have, what are the fundamental differences among the ocean waves, ocean currents and ocean tides? Okay, so this is a very fundamental question which is asked here. Okay, this is a very basic question. The differences among ocean waves, ocean currents and ocean tides. Okay, so these are the three things which we have here. ocean waves, ocean currents, and ocean tides. Basically, here we'll be seeing that ocean wave is basically the movement of energy, okay, from in the form of oscillatory motion. Where energy is transferred from one wave to another wave. Okay, when we talk about the current, this ocean currents, they are of two types, that is surface and deep ocean current. They are developed with the help of, we can say, the prevailing wind, the prevailing winds like easterlies or westerlies. Okay, in the second part we'll be seeing that they are also occurring because of the gravity. Okay, because of gravity. In the third part we'll be seeing that they are also happening because of the density difference. Okay, so under the density difference we have the deep ocean currents. Okay, under the prevailing we have surface ocean currents. Okay, so this we can identify in this aspect only with respect to the development of currents. When we talk about the tides, tides are basically formed because of the gravitational pull of sun and moon over earth, where it is balanced by the centrifugal forces. Okay, where it is balanced by the centrifugal forces, resulting in uplifting of water column and formation of tide or formation of tidal wave. Okay, so we'll be seeing that this ocean tide phenomena, it was very well explained by one of the theorists. He was Harris. So Harris has provided one of the theory, that is standstill theory. So under the standstill theory, he have very well provided that how the ocean tides are formed. Now let's look at how these phenomena are actually taking place. When we talk about a wave, so wave is basically, first it is a ripple when it is having a wavelength of less than 1.6 centimeter, but it become a wave when it is having 16 more than 16 centimeters of its wavelength. Okay, so after this 16 centimeters it becomes fish, 16 and above. Okay, so here we'll be seeing that there is an oscillatory motion. Under the oscillatory motion, there are two things are happening here. First thing is the energy which is being given by the previous wave to this wave. So under this condition, there is development of potential energy. Okay, there is development of potential energy here, and this thing here under the influence of gravity. Okay, so here when it is forming a complete wave, there is a gravitational component also, and under the gravitational component there is a centrifugal forces are also applied. So under the centrifugal forces and gravity, they come to this point. Okay? From trough, they fall down. But they take an oscillatory motion here. They take an oscillatory motion moving to back to the same part here. So what we see in this process here the energy, it is transferred from one wave to another wave in the form of oscillatory motion after it completes a single cycle. And the water which is present here, the water present in the column, it does not move forward, but it performs through and fro motion between the crest and trough. Between the crest and trough, it is just performing a to and fro motion, and the energy is moving in the forward direction. Okay, so they are also called as the progressive waves here. When we talk about the current, okay, for example, in a tropical region, for example, this is we can say this is the region of North America. This is the region of Africa. Okay, here we have the presence of easterlies. Have this part here, and here we have South America. Here also we have easterlies, and this part we have easterlies to this region. But here we have westerlies. Okay, this is 0, 30, 60. Here we have westerlies, and here we have easterlies. So in this way, what we see here that under the basin region, the water is moving in this direction, and in another way, the water is moving in this direction. So this is resulting into the two zones. That is, at one point there is the downwelling zone, and at the another point there is upwelling zone. Okay, so this is upwelling zone, and this is downwelling zone. So in this way, we see that there is formation of surface ocean current. But when we look at the ocean current, which is deep ocean current, here we have the ocean basin. This is Arctic region, and this is Antarctic region. So here, because of the melting of glaciers, the fresh water which is cool and dense, the fresh water which is cool and dense coming out of the glaciers, it is intermixing with the brine, and it becomes more dense, and it straightly move towards the deeper part of the ocean, where the ocean waves, the ocean currents, they start to move up in a opposite direction. Then they are becoming warmer. So here we'll be seeing that they become warm current, and they go back to their destination region. So they are also called as the global conveyor belt of the world. Okay, and in this way we can specify that how the currents are being formed. When we talk about the standstill theory of Harris, which is explaining us the development of the tides. So in this way, what happens? For example, in this particular region, there is the upliftment of the water has taken place. So here two things will happen. Number one, the wave, it will start to move from 1 to region 2. But at the same time, because of the Coriolis force, this wave, it will also move towards it will be deflected under the Coriolis force. So in the northern hemisphere, we have seen that it moves clockwise, and in the southern hemisphere, it moves anti-clockwise. So here, the wave will follow this path, and it will reach a point here. But after reaching this point, the waves, they will again get deflected. And in this case, we'll be seeing that here the wave will again move in two other direction. Okay? The wave will again move in this two direction, but at the same point of time, it will also be deflected by at the same point of time, it will be deflected here by this Coriolis force. Okay? So we will be seeing that these waves, they will be having a certain lag, and after this point, they will be again getting deflected back here, and it will reach this point. But here we have the Coriolis component also, and it will reach again this point here. So when we look at from the, this is the top view. Okay, this is 1, 2, 3, 4, and this is the nodal point. Okay, this is the nodal point. It's also called as antipode. So we will see here that the movement of waves here, it will be in this manner, and after this there will be reflection again, and in the next part they will be moving in this format and they will be reflecting again. So there will be one point in the complete region which will be remaining stand still. So this is the node region, and we also call it as antipode. So this antipode region, it will be remaining in the same place. It will be not moving either up or nor down. So in this way, we see that there is a movement of wave which is taking place, which is basically a tidal wave. And this tidal wave, it is explained very well by the Harris phenomena or the Harris theory. Now, looking at the question again, okay, what are the fundamental differences among the ocean wave, ocean currents, and tides? So here we have explained with the definition what are these three. Then again we are explaining here that how they have formed differently. Okay, then we can see here that what are their applications. So under the application part, we can just see with respect to the development of energy. Okay, we can see the application. Number one, with the development of energy, which is OTEC, that is ocean thermal energy conversion. So this can happen in all the three factors. Okay? It will happen along the waves, it will happen along the currents, and it will also happen along the axis. Okay? Now, second thing, they also help us to understand that what kind of movement is occurring beneath ocean, and they also help us to understand how the climate change is impacting the three processes or phenomena. So with this way forward and their application, we will be able to explain the answer in a very simple format here. Okay. So guys, this is a question which we see that it is based on the fundamental principles of the development of ocean tides and currents and ocean waves. Now moving to the next question.